The unit circle is great if I'm trying to evaluate trig functions of angles that are between 0 and 2 pi, but not all of them are. So for example, what am I going to do if I have the cosecant of negative 37 pi over 4? I don't even know what quadrant that's in. Fortunately, we can figure it out. We're going to use the idea of coterminal angles, angles that start and end in the same place, but have different measures. So negative 37 pi over 4 is going clockwise, the negative direction, and it's going to go around several, I don't know how many times, and it's going to end up somewhere. I don't know. We're going to have a terminal side in some quadrant somewhere. So the burning question is, how many complete times do I go around and how much is left? Where do I land after that? We can find that by adding and subtracting multiples of 2 pi. Well, in order to add multiples of 2 pi to negative 37 pi over 4, I'm going to want to say that. I'm going to want to say 2 pi as something over 4. 2 pi is 8 pi over 4. Adding and subtracting fractions still requires common denominator, just like it always did in all that algebra, you know, still applies. So I'm going to actually, in this case, I'm going to be adding, since that's a negative value, I'm going to add multiples of 2 pi, multiples of 8 pi over 4, until I get something that I recognize, something that's between 0 and 2 pi. So I'm going to go negative 37 pi over 4, and you can add 8 pi over 4 one at a time until you get there if you want. I'm going to recognize, I know 5 times 8 is 40, so I'm just going to do it all at once. If I add 2 pi 5 times, now I have negative 37 pi plus 40 pi. That's 3 over 4, both of them. That's 3 pi over 4. And that's one I know about. That's one the unit circle can do. So the angle 3 pi over 4 is coterminal. That's in quadrant 3. Coterminal with negative 37 pi over 4. And it's one that I relate to better. So I'm going to evaluate cosecant of negative 37 pi over 4 by evaluating the cosecant of the coterminal angle 3 pi over 4. Let's see, that's in quadrant 2. In quadrant 2, the cosecant is positive, since it's r over y. R and y are both positive. Cosecant is positive in quadrant 2. The value of cosecant pi over 4 is root 2. So there we go, positive root 2. One more for good measure. Slide that a little bit. I want to find the cosine of 98 pi over 3. And again, so this one's positive, so we went around in the positive direction quite a few times, and we have a terminal side somewhere. I don't know where it is. But we can use a coterminal angle to figure that out. So I'm going to add and subtract multiples of 2 pi to 98 pi over 3. Well, in order to do that, I need to know what 2 pi is with a denominator of 3. 2 pi is the same as 6 pi over 3. So I'm going to take my original angle, 98 pi over 3, and I'm going to add 6, or I'm not going to add this time, I'm going to subtract 6 pi over 3 until I get something that's between 0 and 2 pi. Again, you can, let's see, if I subtract 6, I'm down to 92, subtract 6 again, and I'm down to 86. That's going to take a long time though. So I'm going to recognize that 16 times 6 is 96. 98 pi over 3 minus 96 pi over 3 is 2 pi over 3. So whatever is the cosine of 98 pi over 3, it's the same as the cosine of the coterminal angle 2 pi over 3, which is in quadrant 2. Again, coincidence. They're not all in quadrant 2, I promise. Cosine of 2 pi over 3. Well, the cosine value for angles that are and in pi over 3 is a half. In quadrant 2, cosine values are negative. Or if you're looking at your unit circle, that's okay. And there's my value.